Hi, my name is Jishnu and I'll be presenting FewSOL, a dataset for few-shot object learning in robotic environments. This work was done in collaboration with NVIDIA. Problem of interest here is few-shot object classification in clutter scenes. Consider a sample robotics environment as shown in this figure. Here, a fetch robot faces a tabletop containing various daily objects. In order to do various manipulation tasks involving these daily objects, the fetch robot has to understand and identify these daily objects fruitfully. Whenever a robot interacts in a human environment, it will encounter clutter scenes more prominently. An example of a clutter scene is shown on the right hand side. The overall goal is that a robot should identify various daily objects in clutter scenes. Our approach to this is object classification using few-shot learning. Let's go over a few of the existing few-shot datasets in the literature. It's clear from the table that datasets in red possess fine-grained classes, for example, aircraft, birds, textures, fungal species, etc. They are not suitable for object learning. QuickDraw, on the other hand, has drawings. OmniGlot has characters. MiniImageNet and MS Coco are more oriented towards internet objects. These are not directly suitable for object learning. The ultimate aim is to learn good representations of daily objects using few examples and generalize well on unseen objects so that it will be useful in various manipulation tasks. For example, moving utensils or objects in a kitchen. Our proposed solution for this is FewSOL, a dataset for few-shot object learning in robotics environments. For each object in the real world, we capture multiple exemplar images of the object. We automate this process using a Franca Amiga Panda arm as shown here. An Intel RealSense camera is mounted onto the Panda arm gripper. It can capture both RGB images and depth images. We specify 9 waypoints of the camera pose and utilize motion planning of the arm to move the camera to these poses. In this way, for each object, we can automatically capture 9 RGB-D images from 9 different views. We have captured 336 objects in total, as we can see here. Apart from the class labels and segmentations, FewSOL also contains object poses. Object poses are computed using AR tags. Because there are noises in the AR tag poses, we use ransack algorithm to estimate the object pose in this process. We provide object class labels and additional attributes for these objects. We leverage Amazon Mechanical Turk for this annotation. In this way, we can gather how lay people name the classes and attributes of the objects, which can be useful to deploy object recognition systems to real-world robotic scenarios. We design 5 questions for each object and ask mTurkers to answer these questions. For each object, we gather answers from 5 different mTurkers and merge their answers. Based on these annotations from Mechanical Turk, we define 198 object classes for these 336 captured objects. Furthermore, synthetic images generated using 330 3D object models are also used to augment the dataset. This comes in handy when doing sim-to-real experiments. In summary, our dataset consists of real and synthetic images of daily objects along with the depth information, class label, segmentation mask, object pose, and attributes. We have benchmarked FewSOL on metadata set benchmark on few-shot classification task. We can clearly see here that cross transformers with SimCLR setup is performing really good. We have also performed joint object segmentation and feature classification. Here, apart from the metadata set models, we have also used pre-trained clip and its variants. Here we can clearly see that tip adapter with its fine-tuned variant performs the best. For the benchmarking experiments, we have used variable NVK shot episodes. Training data consists of synthetic images, testing data consists of real images. Episodes are again divided into 2 based on support set, one comprising of clean support set and the other comprising of cluttered support set. Query set in all the cases are comprised of cluttered images. Our real world setup consists of 32 objects divided into 8 sets, as shown in the figure. The real world setting for joint object segmentation and feature classification comprises of a fetch robot viewing a tabletop containing various daily objects as mentioned on the previous slide. Image is obtained from the fetch camera and a custom segmentation method is used to segment out the objects. Once the segmentation masks are obtained, the objects are cropped and then feature classification is performed. We got really good results using pre-trained clip and its variants. Here are a few more results for other objects. There are two main contributions of this work. First, FewSOL dataset. Different from existing datasets for few-shot learning, our dataset contains daily objects such as personal items, tools, and fruits. We provide RGB-D images, object segmentation masks, object poses, and object attribute annotations in the dataset. Second, benchmarking. We benchmarked FewSOL using metadata set framework. We demonstrated using our dataset for few-shot classification and joint object segmentation and few-shot classification in this paper. From the experimental results, we see there is a need to improve the few-shot recognition performance for real-world robotic applications. We hope that the dataset can facilitate progress on robot object perception. Thank you.